Hello, my lovely students. I welcome you all on this amazing platform. My name is Zishan Ali and I am your mathematics mentor. So today's session is filled with amazing proofs. Proof for what, sir? So today's session is basically why the value of sine theta is 1 upon 2. How this value came? Why the value of sine 45 is 1 by root 2? What is the existence of this value? So in today's session, we will be going through the proof of these values for sine theta. You can also calculate, you can also have proof for cos theta, sec theta and all the remaining trigonometrical ratios as well. So we will be going through the explanation that how sine theta is actually 1 by 2. How sine 45 is actually 1 by root 2 and why sine 60's value is root 3 by 2. So before going into more detail, let me tell you one thing, that whenever you are finding the values of trigonometrical ratios for 30 degree and 60 degree, for 30 degree and 60 degree, remember students, for 30 degree as well as for 60 degree, you have to remember that you will take the help of equilateral triangle. What? You will take the help of equilateral triangle. Getting my point? I hope I'm clear enough. And now when we are talking about any of the trigonometrical ratio, the value of any trigonometrical ratio for a particular angle, that is 45 degree, we will take the help of an isosceles right angled triangle. Getting my point? Isosceles right angled triangle. Now this thing you have to keep in mind before moving on to the concept, right? Now first slide will be prove that, yes, show that sine 30 is equal to 1 by 2. Now how we are going to plan it? See, I have already told you that when we are finding the value of sine 30 degree, that we are going to have a proof of sine 30 degree, that why this value 1 upon 2, why and how this value came. So for that we need an equilateral triangle, as I have already told you, right? Now this equilateral triangle, let us say each side of this equilateral triangle is a centimeter or simply a unit, right? So I will write over here, this is a, this is also a, and this whole is also a, this whole portion, the third side, right? This is also a units or a centimeter, it's up to you, right? Now you can simply see this vertical line, let us name it also, the triangle is A, B and C. Now this vertical line can be said as altitude as well as median for this triangle. Why? Sir, why altitude and median? A common line can be called as an altitude and median for equilateral triangle. What is the reason, sir? So let me tell you again, you must remember that your junior classes had been told you that this line for equilateral triangle is altitude as well as this is median also. Actually in equilateral triangle, altitude and medians are common. The height of equilateral triangle and median of an equilateral triangle both are same, they are common, right? Now if this is median, so what is the work of median, students? Median divides the base into two equal parts, right? If this is A, so what will be this part and what will be this part? Sir, obviously this will be A by 2 and this will also be A by 2. It is obvious, it is obvious. And if this is median, this is dividing the base into two equal parts. And if this is altitude, it must be making angle 90 degree with the base. Got it? I hope this much is very much clear. Now moving on to the half portion of this triangle. Moving on to the half portion of this triangle. Now let me just draw the half portion. This portion, the half portion of this equilateral triangle is A. Let us say this is M. Let us say this is M. A, M and this is C. Now what is AC? We can clearly see that AC is A units, which is actually equal to all the sides of the triangle, right? What is MC? MC is A by 2 and why it is A by 2? I have already explained you why it is A by 2, right? And what is AM? Sir, we don't know. Sir, we don't know what is AM because AM is not an exterior side of an equilateral triangle. So how we are going to find AM, students? Very easy, sir. See, this is a right angle triangle also. We can apply Pythagoras theorem. You know this is also valid. So we will be applying Pythagoras theorem And after applying Pythagoras theorem, you know Pythagoras theorem says hypotenuse square is actually equal to perpendicular square plus base square. I hope this much is pretty clear to you all, right? Now what is hypotenuse? Sir, the side just opposite to right angle. The side just opposite to right angle, which is hypotenuse, that is A. So hypotenuse square is nothing but A square is equal to perpendicular. Let us say AM is perpendicular, right? AM is perpendicular. So we will write AM square plus what is base? Sir, base is A upon 2. We will write A by 2 whole square, right? Now let us calculate the value of AM square or simply AM from this side. Okay, now A square is already A square by 1. Let us write A square by 1. This is A square upon 4, and when we will transpose this from RHS to LHS, this positive A square upon 4 will become negative A square upon 4, students, right? I hope you are getting each and every step I am explaining you right now. Now, we will take LCM and all, we will calculate this and we will get 3A square upon 4. Right? This is equal to AM square. We don't want AM square, we want AM. So what will be AM, students? Sir, AM will be, see, when we will remove the square of this portion, this will go in under root. So this will become, sir, under root 3. A square will come out, so it will be A. And when 4 will be in under root, 2 and 2, 2 into 2. So 2 will be also out, right? So AM is nothing but root 3 upon 2A. So we will write AM over here. Let me just write over here root 3 upon 2A. I hope this much is clear to you all. Okay, now let us move on to next page and let us draw this again. Let me just draw this triangle again so that it is clear to you all, right? Okay. So this is A, this is C, and this is M. Now what was this? Sir, this was A by 2. How much is this much? This is, sir, A. And what about AM? Sir, you have just calculated AM. AM is how much? AM is, sir, root 3 by 2A. Now, students, you all already know about some basic ratio formulas of sine, cos, tan, other trigonometrical ratios. Now, if I ask you, what is sine? And let us take an angle over here. Let us take an angle over here. See, this is how much? Sir, this will be 60 degree. Why this will be 60 degree? Why this will be 60 degree, students? Because, sir, this is an equilateral triangle and this will be obviously 60 degree. This will also be 60 degree. And, sir, this whole will also be 60 degree. But what if I ask you, this line AM divides the triangle into two congruent triangles, right? Two congruent triangles, and this is very basic to you all, right? So how much these both angles will be, sir? These both angles will be splitted like 30 degree and 30 degree. Why both become equal 30-30? See, angle A in whole is 60 degree and angle A is actually bisected by AM. Now why bisected? Very easy. See, both of the triangles are actually congruent, and when the triangles are congruent, these two corresponding angles will become equal. Let us say this is x degree, x plus x will be 60, and 60 will be split into two equal parts, 30 degree each, right? Okay, let us move on to the next page, and this is nothing but 30 degree. Okay. Now, what is the basic formula of sine? I am asking for sine 30. Students, I am asking for sine 30. You just forget 30 as of now. You just tell me what is sine equal to. B upon h, P upon h, or perpendicular upon hypotenuse, whatsoever it is. See, I'm telling you a shortcut to remember. See, some people have curly black hair through proper brushing. This is a shortcut which I actually know. This is some people have. Sine is equal to perpendicular upon hypotenuse, right? So we will be writing it like perpendicular upon hypotenuse. Now you just put the values of P upon H. You will get sine 30 is equal to 1 by 2. See how we are going to get this. Listen. What is P? According to 30 degree, perpendicular is a side which is against or opposite to 30 degree. Perpendicular is having a perfect address. Perpendicular is just opposite to the arched angle. What is the arched angle here? The arched angle is 30 degree. So opposite to 30 degree is MC. So we will write MC in place of perpendicular, and hypotenuse is A only. So we will write A. Right? Hypotenuse we will write AC. Let us write AC. Now we will put the values. MC is how much, sir? MC is A upon 2, sir. A upon 2. Upon, what is AC? Sir, AC is A. A upon 1. Now we will cancel A by A. What we got is 1 by 2. Now this is the proof why the value of sine 30 is 1 by 2. Now what about sine 45? See, for sine 45, we need to draw a right angled isosceles triangle. We can't prove or we can't get the value of sine 45 with the help of equilateral triangle, right? So we will see sine 45 in the other slide, but as of now, let us go for sine 60 as well. Okay? Let us go for sine 60 as well. So sine 60 is equal to, sine 60 is equal to what? Now again the formula of sine is same, perpendicular upon hypotenuse, right? Perpendicular upon hypotenuse. Now what is perpendicular but? Perpendicular according to 60 degree. Sir, according to 60 degree, perpendicular is this side AM. So we will write AM upon hypotenuse is AC. Right? AM is how much? AM we have already calculated, it is root 3 by 2A. So we will write root 3 by 2A. Upon, what about AC? Hypotenuse. Hypotenuse is A, sir. So we will write A over here. A is cancelled by A. What is the answer? The answer remaining part is root 3 by 2. Sir, sine 60 is root 3 by 2 and we have already proved this. I hope you got each and everything which I have explained you for sine 30 as well as for sine 60. If it is done, thank you so much. Bye. Take care.